Okay, everyone. So, does anyone know what the mascot of GitHub is?
A cat.
A cat.
Close. Any other guesses?
Alien.
An octopus.
A cat.
It's
yes,
me.
it's Octocat. Good job.
What?
It is part octopus, part cat. Yeah. Okay, so Git is a version control system, and GitHub is the interface that uses Git. So what a version control system means is that it's a system that allows you to keep track of different versions of your code. For example, Google Docs is kind of like Git in the sense that every time you make an edit to your Google document, you can see who made the edit, when it was made, and what edits they made, as well as every possible version of the document. So repositories are what you think of folders for all your code. And you have repositories on your local machine as well as in a remote server, which is on github.com. And Git was created by Linus Torvald, who's that guy over there. He also made Linux, so who here is using a Raspberry Pi for their project? One person, two. All right, so you can thank this guy making Linux. So yeah, why does GitHub matter? It's pretty useful because it works on every operating system, so Mac, Linux, Windows. And it's also used all over industry. For example, it's used in Google, and it's they use something called GitHub Enterprise, which basically allows you, everyone in Google to have access to the repositories they need to have access to. And so they have some projects that have thousands of lines of code. And obviously, if you're working with that much code, you need to know exactly who makes what edits and keep track of all those to make sure people are doing their job properly. Microsoft also bought GitHub in 2018. Does anyone know how much they bought GitHub for? Any guesses? No guesses. Okay, well, it was $7.8 billion, so
Damn.
quite a lot. GitHub is also used in colleges and some high schools, and it's really useful to make a GitHub profile because then anyone can see the code you made just by using a web browser. Like for example, if you sent someone your Arduino code, they wouldn't be able to open it up because if they don't have the Arduino IDE installed. However, if you use GitHub, you can just upload the code to GitHub, as I'll show y'all in a demo, and if you just click on the code, it just shows it all in HTML, which stands for Hypertext Markup Language. It's also very useful because it acts like an IDE in terms of it shows you all the different loops and all keywords are in different colors. But the difference is that on GitHub you can't actually run any of the code. So you will have to use an IDE and then save your code in a special folder, which GitHub will then be able to access. So as I said earlier, a repository, you can think of it as a project or a folder where you put your files. And then commits you can think of as like edits, like every line of code is a new commit. But you don't have to post a commit every line of code. I recommend posting a new edit or commit every 10 to 20 lines of code, or whenever you achieve something that's really significant and you don't want to lose that progress. So branches are something that we won't be using, but if someone makes an existing project that's on GitHub and you want to copy their project but use it for like hack it, kind of modify for a different purpose, you can make a new branch. Like for example, when people make Pokemon Go bots, if you want to use it for a different game, you can make a new branch and edit it. But there's always a main branch, which is generally the people who designed the original project and know what they're doing. So yeah, Git is also very useful because it can be used for any type of language. Yeah, assembly, C++, Python, Arduino, C processing. So any type of code you write, you can use GitHub and Git for it. And also, Git is more powerful when you use Bash. You use a program called Git Bash. We're not going to be doing that, but everything that we're doing with GitHub Desktop, you can also do in Bash. Bash is that command line interface that Macs use, as well as other operating systems. So this is a reference sheet of all the Git commands and how to use them in Bash. We're not going to be using these commands, but the GitHub desktop app will do these commands behind the scenes. So let's keep that in mind. So how Git works is that whenever you want to make edit to a repository, you first pull the repository onto your local machine. So your local machine is like a computer, and the remote machine is the GitHub repository that's on the server. So after you pull, you can edit the file, and it's really simple. You can just open the file in your IDE and make an edit. And after you save it, GitHub Desktop will automatically recognize that you made that change. And after you make a change, you can go ahead and push the file back onto the remote server. Does anyone get this joke over here? Okay, so let's say if there's a fire, you should first commit your code, then push it, and then exit the building. So you should always save your code first. That's actually how you save your code. Git. So please don't do that. Actually leave this fire. Okay, now it's time for a demonstration. Is there any questions about what the previous slides covered? So yeah, everyone please open up the GitHub desktop app. You can install it. It looks like this, and at some point it's going to prompt you to make a GitHub account, so please do that. And to start, we're going to go to File, Repository. Did everyone manage to get GitHub Desktop? We don't need more time for that. Okay. So, we'll make a new repository. Let's call it test. And it's going to select initialize with a README. What a README is just a file that shows other people how to use your programs and how to use your project and how to install them if they haven't used it before. So, create a repository. And so far what I've done is I've made a repository that's on my local machine. So if I go to Documents, GitHub. So yeah, GitHub makes a special folder. It's called just capital GITHUB, and this is the local repository. I mean, the file containing the local repositories. So you can see a v3 demo is here. There's nothing in it so far except a README. But if we want to make this repository go online, I'm going to click this button to publish a repository at the top. Publish. And what fetch origin means is it's like pulling the files onto your computer. So now if I go onto my GitHub account, I'll refresh it. It's going to show this repository, but so far it's boring, there's nothing in it. To make this more interesting, you have to put some code. So I just opened up Blink, which you can get by doing File, Examples, Basics, Blink. And what you want to do to all your Arduino code that you want to upload and back up on GitHub is to save it in that repository folder, which would, in my case, be in Documents, and then GitHub, and then repository link. Yeah, here. I can just save it here. now GitHub Desktop will automatically realize that I uploaded some code. So this is supposed to be green color, and we see it as well. But green code, it basically means that you're adding code. Red code means that you're getting rid of that line. So now, over here, there's that box, which is every time you add code or you make a commit, you want to write a description. So I'm going to say added code. I'm going to say I can go ahead and commit it. So that's the change. But the change has only been made on my local machine. If I want to make it happen at the server, I have to click on the push origin button at the top. And I'm going to go ahead and do that. And it was saying for delta, so basically every delta is just a change. This is Git's way of saying, oh, it made change. So now if I refresh this, it should show the code. We can actually see the HTML interface for code. So yeah, right here, this folder will have the INO code. And if we click on it, it shows kind of Git's interface. You can't see the colors too well, but basically it shows blue for all the functions, red for all the return types, and purple for all the methods. So yeah. So now if we make a change to like if we make it go on for 1 second, turn off for 1 second, and turn on for half a second, and then turn off for half a second. So basically having it blink faster, we can make an edit and then Git will recognize that. So now we're just going to save this, and Git will, and also at the same time I'm going to get rid of some of these comments, give them credit. It's not good practice, but just for demonstration. Oops. And yeah, all the code that got deleted is in red. All the code I added in green. So now we can commit this change to master, so added function. So you have a title, and then you also have more description of what you did, so news, comments. And then just commit it to master, push origin, so it's the same process as what we did before. It's going to resolve the changes. Now, go to Chrome, you look at the repository, and look at the code. It's going to be updated. So this is pretty neat, but what's really helpful in Git is if you go to your repository, you can see every change that we've made so far. And if you have multiple people working on code, it's really helpful to use Git, because if one person makes a change, then everyone can see that change. And also, as long as you're pulling the code every time. Oh yeah, you have a question.
Like, won't people override each other's like changes?
Oh yeah, good point. So if you pull the code beforehand, and then edit the code and then push it, Git will automatically make sure that you have the most recent version, so you don't override the same code. But if you forget to pull the code, and you both you and your partner push code that you edited, then you have something called a merge conflict. That's pretty tough to deal with. You have to go line by line through all the code and see which one's correct. But yeah, great question. So if we go under commits, you can see each modification I made. And for example, if I click on added code, it just shows that I added a code. This is all in green. And for modification of length, in red, it shows this part, which is the lines, the comments I deleted, and then in green is the lines of code I added. Yeah, everyone managed to get a desktop to work and make a repository and put some code in it. Let me know if you have any more questions about this process. It's pretty useful for when you make different versions of your code, Now we're going to look at some example repositories, just to show how Git is useful for when you use multiple different files and you have to link them together. So for instance, for one of my classes' final project, I made a plagiarism detector. You can see this more fleshed out repository. I have a README explaining Linux commands you need to run this. I also included something called a makefile, which is in Linux when you want to make a file that has instructions for how to compile all the different files and make them run properly. It basically gives instructions for them. Also for all the C++ files, it shows all of them, shows different classes that you use. Any more questions about Git? All right. Those are my tools used. And oh yeah, one more important note is that you should definitely back up your code somehow every couple of milestones, and also every couple of lines of code in between milestones. So either copying and pasting your code into a document, or if you want to try using GitHub. It's really useful for that purpose as well. Yeah, so let me know if you have any questions or if you get it all. Feel free to email me questions or send me your sample repositories. Yeah, those are some more user manuals. If anything was unclear from my presentation, feel free to check it out and give me more information. Good luck with all your projects.
Does anyone have any questions for Aditya? No? All right. Well, thank you.